Hello, how are you? Welcome to a new video from the AbadIA in its most agentic version. Today we are going to talk about multi-agent systems and how the Google ADK helps us in this project. But I won't keep you any longer. Let's get started. Tough problems like cracking a murder mystery in a huge, ever-changing game world like AbadIA are often just too big for one AI to handle alone. So, bringing in the idea of specialized digital teammates working together is super important for tackling this kind of complexity. What is a multi-agent system MAS? A multi-agent system, MAS, is a fundamental, cool area of research in modern artificial intelligence. A MAS is made up of multiple decision-making entities, which we call agents, that hang out and interact in a shared environment to hit common goals, or, sometimes, even go after conflicting ones. The main reason we use multi-agent systems is to solve complex, multi-step, and huge problems by putting the unique skills of individual agents to good use. Think of MAS like a team of human specialists, where each member brings their own special talent to achieve a group goal that's bigger than what any single person could do alone. How MAS conceptually work: teamwork makes the dream work. MAS operate by spreading out tasks and sharing information among their individual agents. Each agent throws in its specialized talent and learns from its interactions within that shared environment. There are mainly two ways to set up multi-agent systems. Centralized network. In this setup, one main server, acting as the big boss, controls all the interactions and info sharing between every AI agent. This makes communication simpler and standardizes information, but if that one server goes down, everything goes down. Uh-oh. Decentralized network. On the flip side, in a decentralized network, AI agents handle talking directly to each other, no single boss server needed. These specialized agents all get the same picture and share responsibility for the group goal. While this setup is tougher and can scale better, it means more complicated coordination among the agents. Collaboration is a key strategy in MAS, letting agents achieve more than they ever could solo, filling gaps that would otherwise be ignored and acting more like a human team. Common interaction patterns in multi-agent systems include router agent. One by one, a central agent gets the first request and then passes it along, one by one, to other agents, acting like a go-between to decide which agent is best for each part of the job. For instance, in a strategy game, a command agent might get a player's order and tell a building agent to build a base, then a training agent to make units, and finally an attack agent to go on the offense. Parallel, one-to-many, a single agent hands out subtasks to multiple agents all at the same time. This works great when the subtasks don't depend on each other and can be done simultaneously, seriously cutting down the total processing time. An example would be an exploration agent in an open-world game telling several reconnaissance agents to map different areas, all working at the same time in separate parts of the map. Sequential. Predefined sequence, this involves a fixed flow of info between agents, where what one agent finishes goes straight to the next in a set order. For example, a resource gathering agent digs up materials, passes them to a processing agent that refines them, and then to a storage agent that puts them in the game's inventory. Circular flow, predefined sequence similar to the sequential pattern, but the info flows in a loop, where what the last agent finishes goes back to the first agent, creating a cycle. This is handy for things that need to be done over and over. A mission design agent might create a mission, a testing agent would check it out, and if there are problems, it would send it back to the mission design agent for fixes in a continuous loop. Dynamic, all-to-all in this more complicated setup, any agent can talk to any other agent. There's no central boss or fixed flow. Agents dynamically chat and negotiate to hit a common goal. In a city simulation game, traffic agents could talk directly to public transport agents and pedestrian agents to change traffic lights and routes on the fly, without anyone centralized telling them what to do. MAS work through teamwork and coordination, where agents chat, share info, and change their behavior to hit group goals. Real-world examples are everywhere, from traffic management and public transportation, where agents talk to each other to make things flow better, to factories with tons of robots coordinating tasks on assembly lines. They're also used in customer service, supply chains, and smart power grids. For AbadIA, this could mean different specialized agents. One agent focused on finding its way around the Abbey, another on analyzing dialogues for clues, a third on managing inventory, and a fourth on sticking to monastic rules, like showing up for prayers. These agents would need to coordinate to solve the crime. The agent's ability to mimic human social skills like cooperation, coordination, and negotiation is a big deal. Plus, LLMs can be used inside MAS to understand human language and chat back, which makes orchestrating things among agents a breeze. Multi-agent systems offer a neat fix for the jagged intelligence of LLMs, where they're awesome at some things and totally stunk at others. By using a MAS approach, instead of trying to build one giant AI that's good at everything navigation, talking, puzzle solving, time management, you can create specialized agents. For instance, a navigation agent could be a whiz at finding paths, while a dialogue agent would be a pro at understanding character chats. This modularity directly tackles that jagged intelligence problem, making the whole system tougher and more effective for a complex game. However, getting new systems to play nice is a bit of a puzzle. While MAS have benefits, decentralized networks, in particular, need more complex coordination. How agents interact and are managed, orchestrated, is super critical. For AbadIA, designing that orchestration layer, how agents decide who does what, when, and how they share info, will be a major architectural challenge. This sets the stage for our later chats about Google ADK and Vertex AI Agent Builder, which are tools built for just this kind of thing.